Hello. In this video, we're going to talk about the probability distribution of a random variable and how are we going to assign it to different values of the variable. So from the definition, the probability distribution for a random variable describes how probabilities are distributed over the values of the random variable. These distribution are commonly expressed in a tabular manner because it is the most common way in showing the probability distribution. It can also be described through a graph or through a formula. There are two types of assigning probabilities to random variables. The first type is the manual assigning. That means we have to put the probability of a certain event in the table by ourselves and will not rely on formulas. The second type is when we use special mathematical formula to compute for the probabilities, and after computing it we will put it in the table that corresponds to the value of the random variable, and this could be further divided into four parts: the discrete uniform distribution, binomial distribution, and Poisson's distribution, and hypergeometric distributions. But this second type of assigning probabilities will be discussed on the next video. So for the meantime, let's focus on the first type, which is the manual assigning. The probability distribution is defined by the probability function, commonly denoted as f of x or function of x. And this particular function gives the probability of each random variable. There are certain rules to follow here. The first one is that the function of x should be greater than or equal to 0. That means each probability of a random variable should not be less than 0 or a negative value. The second one is that the summation of the probability of all the random variable in a certain event should be equal to 1, or in percentage form it is denoted as 100%. These are ways to check if the probability distribution of a random variable is correct or not by simply testing if each probability is greater than or equal to 0 and that the sum is equal to 100%. The first common example of the assigning probabilities is the dice roll. We know that a common die has 6 sides numbered from 1 to 6. That means the possible outcomes of a single roll of dice are 1, 2, 3, 4, 5, and 6. And we will denote this as the variable x because this is the random variable. The next one is the probability. That is the function of the random variable x. What is the probability that the number 1 will show after we roll a dice? That is 1 over the total number of possibilities, which is equivalent to 6. Same goes with the number 2, that is 1 over 6, as well as the other possible values. So this is the probability of each value to come out in a single roll of a common dice. Adding all of the probabilities will give us a value of 1 or 100%. This kind of assigning probability is what we call the classical method because all of the possible outcomes of the random variables are equally likely. That means they all have the same probability that all of the possible outcomes will occur when we do the experiment or a certain event is being done. The next example we have is the vehicle sales. For example, for the past 300 days, a dealership experienced 54 days with zero sales, 117 days with one vehicle sold, 72 days with two, 42 days with three, 12 days with four, and 3 days with five vehicles sold. To make this a probability distribution in a tabular manner, let's start with the variable x. So there are 6 possibilities here, which is 0 sales, 1 car sold, 2, 3, 4, and lastly 5 cars being sold. The function of x, or the probability, is equivalent to the number of days that this particular event happened, which is 0 car sales, divided by the total number of days being tested. In this case, that is equivalent to 300 days. So, for 0 car sales, 54 days divided by 300 days is equivalent to 0.18, and this probability will depend on the tolerance on the number of decimal places required. But for this particular example, we'll only be using 2 decimal places. For one vehicle sold, that is equivalent to 117 days divided by the total number of days. So that's 117 divided by 300, and that is equivalent to 0.39. 2 amounts to 72 days divided by 300, or that is 0.24. 3 is 42 divided by 300, and that is 0.14. 4 is 0.04, which is 12 divided by 300, and 5 is equivalent to 3 divided by 300, or that is 0.01. Adding all of the probabilities is equivalent to 1. And this is the criteria that we have to meet to make sure that our probability distribution is correct. Also, all of the probabilities are positive, so we are sure that our distribution is correct. The use of the relative frequency method to develop discrete probability distributions leads to what is called an empirical discrete distribution. For other ways of doing probability distributions, stay tuned for the next video. Thank you very much for listening.